Okay, kids, welcome back. You're like, who's that new guy teaching us? He's got such a fresh haircut. It looks so awesome. All right, I finally cut my hair. It is summer. Let it go. Looks good though, doesn't it? Man, got it all shined up for you. Hoping the lights aren't doing too bright for you. Anyway, here we are. By the way, if you haven't subscribed yet to this YouTube channel, please do so. It helps us out, helps you out, helps us out a lot. Actually, the more subscribers we have, the better we're doing. And with YouTube, and the more things that we can get in order to build our business. Our hope is next year to tackle course 1, Algebra 1, Geometry, and probably pre-calculus. We're gonna be stretching on that one, but hope that's our goal, and then eventually calculus. So if you stay with us and you subscribe to us in the future, you should have some good videos. Definitely going to be doing calculus in the near future. So stay with us. Anyway, all of this information can be found at www.Newman Krause Infinity. That's how long math class takes. Actually, that's how long social studies class takes for me. Because I wasn't a good fan, but now I like it. I wish I was a little bit more mature when I was young. Anyway, who cares? Why are you listening to me about that stuff? Nobody cares. You want Mr. Key to show up and help you out. Oh gosh, I'm so funny. All right, so what I have here is a bunch of graphs. I told you yesterday that you need to be able to recognize the graphs based on the equations, or be able to say, okay, I know what these equations are. Here are the equations, and here are the graphs. Here are the equations, and here are the graphs. I'm just having fun. Okay, so let's do this first. Here's what I would suggest. First of all, I would suggest you pause this and try these on your own. See how you can do. Okay, and then come back. So pause. And I'm going to do this in black. Why haven't you paused yet? Stop looking at me. You can't stop shining. You guys look at this gorgeous haircut. Oh, man, feels so good. Whatever. All right, you're back. All right, great. So here's what I'm going to do first. I'm going to say this is a cube root. This is a cube root with a reflection. This is a square root. This is a cube root. This is a square root. A square root. And these, all three of these, this has a reflection, this has a reflection, this has a reflection. And this one is just a square root. So now I'm going to tackle the square root functions first. Notice I have four square root functions, and three of them have a reflection. Three of them have a reflection. One of them does not. The reflection, if you remember, the reflection comes from taking the negative square root. So I need to find one that's not negative square root, and that's going to be negative. That's going to be number 7. And not only that, notice how small it is. Normally I go over 1 and up 1. I go over 4 and up 2. This one went over 1 and up, it looks like maybe a half. So not only am I looking for a square root, I'm looking for something like a half out front and a positive number. All right. And, not only that, it moved to the right 3. That means it's got a minus 3 underneath. So I'm looking for something with an x minus 3. And it went down 1, minus 1. There it is. Now the other 3, I'm going to try to write the function right here. I'm going to try to write the function right on this graph. So let's use orange. All right. So I know it's negative square root. I know it didn't move left or right at all. Notice it just went up. So that means plus 2 on the outside. It didn't move left or right, so the only thing that's going to be underneath there is a plain old x. Now it went over to the right and down. So 1, 2, 3, 4. So I'm thinking there should be a negative 4 out front. So let's see if I can find a negative 4 square roots of x plus 2. Oh, there it is right there. It's h of x. All right, let's do this one. This one moved to the right 3 and up 2. So I know it's going to have x minus 3, right 3, and up 2. That's a plus. I also know it's going to have a negative out front. Now, let's see how much of a negative it's going to have out front. I went to the right one and down 1, 2. So it should have a negative 2 out front. So I'm looking for this, negative 2 x minus 3 plus 2. Negative 2 x minus 3 plus 2. So that was f of x. This was k of x. This is f of x. All right, and finally, I only have one left. I could cheat, but I'm not going to. Notice it didn't move at all. It didn't move at all, so it's just going to be a negative square root of x. Nothing on the inside, nothing on the outside. But I went to the right one and down. This would be down 1. It didn't quite go down 1, so it's going to be something smaller than 1 out front. No movement out. There it is right there. Negative square root of 4/5. Now 4/5 is close. What is that? M of x. So, oh, this one was h of x. This one is m of x. Sorry, got them in the wrong circles. M of x. All right. So now we got our cube roots done. Let's go to our cube roots. This one is going to be a normal cube root that moved down 5. So x down 5. So, and we also went to the right 1 and up 1. So that's just a normal cube root left. Down 5, there it is. J of x. J of x. This goes up and back, but man, it moved to the left 4, so that means it's going to be a cube root of x plus 4. Didn't move up or down, so nothing here. But it does have a stretch to it. Notice if I go to the right 1, I go up 2. So that should have a 2 in front. Ooh, look at this, look at this. I picked a cube root function over here. Did I pick another cube root function? What's J of x? Which one did I pick J of x to? Oh, yeah, I did pick J of x. I already used that one. Which one used plus 4? This one used plus 4, and it's got a 3 out front, but it's got a minus 1 there. Oh, maybe I missed that. Oh, look at this. Wait. Look at this. This is where it is. Ah, so I was a little bit off. That's where the thing is. So it actually moved up 3. That's why it's got a 3 out front. So I was close. That was a tough one because that was tough to see where it was. Let me erase what I got here, right? So I thought it was here, but it's actually here. So I went right 1 and up 3. And that means I also moved to the left 4 and down 1. All right, so the final one is this cube root. It's got a negative out front. But other than that, it should be just about normal, except it moved to the left 2 and down 3. So it should be plus 2 and minus 3. There it is, right there. L of x. Sometimes I have such a hard time moving this thing. L of x. All right, we're done. Oh, that's just the first page. All right, see you in a few minutes. For me, for you, it's a few seconds. All right, that was a couple minutes for me by 2 seconds for you. Not even 2 seconds. All right, let's move. Let's go to page 2. Write the equation of the new function and describe the transformation that occurred. Am I recording? I am. So what we're going to do is we're going to write m of x. So m of x is equal to n of negative x plus 3. Well, I don't know what n of negative x is. So let's see what n of negative x is really equal to. N of negative x is really equal to, we're going to plug negative x in. This negative x in gets plugged in here for x. So it's really equal to 2 cube roots of negative x. Okay? All right, so m of x is just equal to 2 cube roots of negative x plus 3. So my question is, how does this Write the equation for the new function. That's the answer. That's the first part. That's the equation for the new function. Describe what transformations that occurred. So how does it differ from n of x? So the negative x, if you remember, this is a this is a reflection in the y-axis. Remember, negative on the outside is reflecting over the x-axis. Negative on the inside is reflecting over the y-axis. So reflection in the y-axis, and it had a transformation or translation. That's the actual word. Translation up 3. All right, let's do the next one. Q of x. Well, Q of x is 1/2 of P of x minus 2. So let's figure out what P of x minus 2 is. That's equal to the cube root of x minus 2 minus 4. So that's what P of x minus 2 is, and that has to go in here. So Q of x is equal to 1/2 of the cube root of x minus 2 minus 4. All right, so now we got to distribute. So Q of x is equal to 1/2 the cube root of x minus 2 minus 2. Right, because half times 4 is minus 2. So that's my new function. There's the first part of the answer. That's Q of x. Make sure it matches my answer key. Well, that doesn't match my answer key. I think my answer key is wrong. So P of x minus 2, you put x minus 2 in for that. Minus 4, distribute, you get 1/2, x minus 2 minus 2. Okay, so lots going on here. So let's see what the translation is, or the transformation is, excuse me. So because I have this 1/2, and I did not have this 1/2 before, let's look at what the before was. There wasn't a 1/2 before. So that's a dilation of 1/2. Means it got less steep. It also moved, we have this minus 2, which we did not have before, so we went right 2. Now here comes the tricky part. I gotta fix my answer key. Here comes the tricky part. It was at minus 4. It's now at minus 2. So it was 4 units to the right, but now it's only 2 units to the right. So it actually moved left 2 units. Wow, that's a... Excuse me. It was 4 units. I got myself confused there. Sorry about this. This minus 4 at the end. Let me show you this minus 4 at the end. Let me get rid of some of this work. This minus 4 at the end, it was down 4 units, but now it's only down 2 units. That means it went up 2 units. That was a tough one. All right, let's do this last one. Hopefully I got this last one right on my answer key. Okay, so I want to figure out what this is equal to. I'm going to figure out what this is equal to first. So I'm going to come over here and I'm going to say, okay, r of x plus 3 is equal to negative 2 x plus 3 minus 3, because that went in for x, plus 2. So this is equal to negative 2 square roots of x plus 2. Notice the 3's cancel. All right, so this is really this thing right here. So t of x is equal to negative 1/2 times this mess. Negative 2 square roots of x plus 2 minus 2. All right, so t of x is equal to, now we got to distribute. Let me get my, let's see, red pen. Negative 1/2 times negative 2 is just 1, so that's just square root of x. And negative 1/2 times 2 is negative 1, and then minus 2. So t of x is really equal to the square root of x minus 3. Woo, man. So find the equation of t of x. Oh, and describe the transformation. So it was reflected over the x-axis, so we're going to reflect it back over the x-axis. So we have a reflection over x-axis. Now, you're saying there's no negative out front. Yes, remember, though, there was originally, remember, we're going to compare it back to this one. Originally, there was a negative in front. Now we have a function with no negative in front. So originally, there was a negative here. Now there's no negative. That means whatever that function was, my new one's reflected back over the x-axis. Notice it was 3 units right. But now it's not 3 units right, so it moved, or it's translation, I should say translation. Let me use the proper words. I've got a translation 3 units left, because it was 3 units to the right. Now it's not 3 units to the right, so it moved up. Now it was up 2, and now it's down 3. So if it was up 2 and now it's down 3, that's a translation down 5. All right, let me stop right there. I'll be right back. Okay, let's see where we're at now. Let's see, we're going to graph this puppy. How is this thing going to look? Let's see. Pretty simple. We're going to take, I'll plug in 0. Let me just do this in red. I'll do it in black. It's a good black. Plug in 0. I get 0. If I plug in 1, now that's interesting. If I plug in 1, that's not going to be a nice number. If I plug in 0, I get 0. If I plug in 1/3, I get the square root of 3 times 1/3, which is equal to the square root of 1, which is equal to 1. 1/3, 1. Now I want to make that thing a 4. So I'm going to do 4/3. So let's see if that makes sense. 3 times 4/3 is really equal to the square root of 4, which is 2. Now 4/3 is right about here, and that's going to be 2. Now I want to make that thing a 9. Well, that's easy. I just plug in a 3. And if I plug in a 3, that's the square root of 3 times 3, which is 9, which is the square root of 9, which is 3. So 3, 3. All right, so I've got those. The next perfect square would be 16. So I think the next thing I should use is probably 16/3. Now let's watch. 3 times 16/3 is equal to square root of 16, which is 4. Now 16/3 is 5 1/3. So 5 1/3, it should be 4. Alrighty. All right, that's about what it should do. All right, there it is. So if g of x, now what did they call this thing? They call this thing f of x. So let's call this f of x. G of x is f of x translated, g of x is f of x translated. This is g of x translated. What's going to happen? It's going to go down 2. Well, that was easy. This one, we got -4, so anytime it's inside the parentheses, that means it's going left or right and backwards. So we're going right 4. I should say this is a translation. I should use the correct words. Translation. And then let's see what the last one says. Given the graph of the square root function, oh, so this has nothing to do with that. All right, so 12. Given the graph of the square root function, here it is. If k is increased by 4 units, how would the graph of the new function? So let's just make up a number. Let's just make up an original number. So f of x, let's say this was the function, -2 square roots of x plus 1. Okay, let's say k was 1. Well, wouldn't that mean that originally the graph would go up 1 unit? But now I'm going to increase k by 4. So now my new k is going to be 5. How does it affect the change? Well, it moves, it translates, it's a translation up 4 units. Because it's on the outside and I'm increasing it, that means it's going to go up 4 units. All right, so now we're going to write this as a piecewise function. Yesterday we couldn't have done this. Last unit, I mean, when we were doing piecewise function, we could not have done this, but now we can. Now we can grab this thing. Now we can name this thing. All right, so it's a piecewise function. We're going to call it f of x. And we've got 3 pieces. All right, so this piece is easy. It's just -2. So it's equal to -2. And we're going to say that's from -4 less than or equal to x less than -2. I'm just not going to put the equal to there. I'll put it on the next one. Now this one, does this look familiar? Square root function. That's equal to, now wait a second, it was a square root function moved left 2 and down 2. So this is the square root of x plus 2 minus 2. And we're going to do that from -2 less than or equal to x less than +2. And finally, this is just a linear function that's got a slope of 1. I just got to find its y-intercept. Ah, there it is. So it's -x plus 2, and that's from 2 less than or equal to x less than or equal to 4. There it is. Piecewise function. How'd you do? Okay, so on this page, I talk about how to use the TI Inspire to do power regression. So these will be the steps that we're going to be using in the next couple of pages. So if you have this calculator at home, you can do this as well and use these steps in order to find power regression. Now, power regression forms are in the form of f of x equals, and it's right here, a times x to the b power. Now, it could be a half, it could be a third, it could be a fourth, it could be a square root, it could be a cube root, it could be lots of different things. All right, so it's got to that power. So we're going to use our graphing calculator to do some power regression. So I'm going to come over to my calculator. And I got to remember, to do regression, you have to go into the spreadsheet. Now, I'm going to call these two things whatever they are. So if I go back, one of them's called year and one of them's called length. Oh, wait, average year and length. So I'm going to call this year because that's my independent variable, and this length. So this is my X list and this is my Y list. So my X list is going to go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, that one was easy. This one won't be hard. 47.6, 58.7. While I'm doing this, one of the most common mistakes made is not typing in the numbers correctly. Hopefully I'm going to do that and I get the same numbers as I did before. At least I have an answer key that I've created before to make sure that I end up with the right answers, but who knows. Generally on the Regents exam, what you're going to want to do is do these problems twice, just to make sure that you did not mess up the numbers. And don't just go look through your list and go, oh yeah, I didn't, you know, actually go through and redo the problem another time. Don't be lazy. All right, do it twice. Since I have my answer key already here, I can check it with what I did before. All right, so I'm going to go into Menu, Statistics, Stat Calculations, and we're going to do Power Regression. It's down here at number 9. All right, what did we call our X list? Remember, our X list is our independent variable. That's this one right here. That's the year. So we called that one Y. And then the other one was our L list. And I click OK. And there's my power regression. Now, I probably should have graphed these things first. Let me graph them first. Let me create my scatter plot. OK. I'm going to shrink this up a little bit so I can see a little bit better. And I can move it off. Okay, so down here at the bottom, Down at the bottom, 0, 0. I got to get up to 12. So let me just count every one of them as 1. So this is 2, 4, 6, 8. This is definitely a different graph than I have on my sheet here. I'm going to call every 2 of them 1. Oh, no, I don't think I'll get there. 2, 4, 6, 8, 10, 12. Good enough. Now, this one, I have to get up to 109. I don't really want to have a break. I'll just put a little break here. And we'll call this 50. And we'll call this, let's see, 60, 70, 80, 90, 100, 110, 120. So this will be 120, 110, 100, 90, 80, 70, 60, and I got 50 right there. Okay, so we're in good shape. All right, so down here is the year, by the way, and over here is the length. 2, 47 point, so right about there. 3 is just about 60. I wish you wouldn't do that. 4 is just about 70. 5 is just about 80. 6 is 82. 7 is 87. 8, oh man, that's so annoying. 8 is 96. 9 is 106. I hope you fast forwarded through all this. 10 is 114. And 11 is 112. And 12 is 109. It's coming back down, looks like. So it almost looks like a linear function, and I might be inclined to use linear regression on this. May not go badly, but that's not what they told us to do. They told us to do a power regression. So the first thing I'm going to do is write down the equation. F of x is equal to, now I probably should be using the letters that use L of y. We're going to do L of y is equal to a times y to the x. It's kind of an icky equation, but whatever. Or to the b. To the b, to the b, to the b. If you don't like using that, you could go back to this. I'm sure nobody would actually care. Y equals a times x to the b. Because that's the equation that's given on your formula. That's the equation given right there, a times x to the b. We got to write down what a is. We have to write down what b is. Please don't write these down unrounded. 34.4119, 34.411944, 119448. That's probably enough. I like to get out 6 or 7 decimals. B is 0.49437, 0.49437,964. By the way, if you can't read those, your calculator may look like this. And if you can't read those, just click on this. And remember, the number will appear right here on the bottom. I know you've been staring at the top of my head for a while. Sorry about that. The number will appear right here at the bottom. So now I'm going to write it, rounding all coefficients to the nearest tenth. So y equals 34.4 times x raised to the 0.5. And that's what I had before. So there it is. So the question is, use your model to predict the length of 14 years old. So this is generally not we're extrapolating. We're not interpolating, we're extrapolating. Extrapolating means you're going past the data. I want to go past the data. This is extrapolation. When you go past the data, it's extrapolation. When you use inside here, like if I asked you about 5.5, that would be interpolation. That's inside the data. Outside, extra, on the extra. So we're going to extrapolate a little bit from this information. We're going to check to see what it would be at 14 years. So y equals 34.4 times 14 to the 0.5. That I'm going to have to do on my calculator. So 34.4 times 14 raised to the 0.5. And I get 128.713. So y equals 128.713. It didn't say round. I'm going to round it to whatever the other ones were rounded to. And I think they were rounded to the nearest tenths. So I'm going to round this one to the nearest tenths. So y equals 128.7. Perfect. All right, so I walked through that whole one right there. But, if I was you guys, I would pause the video or scrub through this video, because these numbers are going to be a pain to put in. So data below shows the total gray matter volume for a group by age. Age in months spanning from 5 to 37 months. So I actually have 2 charts here. I'm going to use the high SES and the low SES. So we're going to do high SES first. Socioeconomic status. The table below shows children from low socioeconomic status, high socioeconomic status, and the total amount of gray matter they have. So let's go grab our calculator. And again, we have to go do another regression and see how this one's already in here. You don't really want that, so let's get rid of it, choose not to save, and then go back in. So now you're really just working off tab 1. And we got age and SES. So we've got age and SES. And that was called high. So might as well, maybe we'll call it HSES, high SES. So let's see. Ages 5, 9, 13. I'm going to just use my paper here. 5, 9. Again, you might want to just scrub through all this. I'm just typing in the original numbers. Whoa. 5, 9, 13, 17, 21, 25, 29, 33, and 37. And we're going to do 50,000, no, 500,000, 540,000, 579, 6112, 639, oops, 662, 677. Again, most common mistake, typing in the numbers wrong. Like that, screwed something up. So 5, 9, 13, oh, I forgot 13, 13, 17, 21, 25, 29, 33, 37. And this one should be 700. All right, so I got them all in there. Let's do some, so this direction say, use the power regression for, oh, they want low SES first. We did high SES, so I'm going to do this one first. So menu, stats, statistics, power regression, age, and high SES. All right, so come back here. Y equals A times X to the B. What is A equal? What is B equal? A is 371, 916.35105. And the other one is 0.176306. 0.17630619. So my equation is y equals, we got to round to the nearest hundredth of a thousandths points. So this is tenths, hundredths, thousandths, hundred thousandths. Tenths, hundredths, thousandths, 10,000s, 100,000s. Holy mackerel, I got to go out more. This is why you don't want to round. See, I'm going to click on that and it tells me the whole thing. 5021, 521. Oh, hold on a second. Nah, that's what I was trying to wonder why they want to do 100,000s. So A, we're going to round to the nearest 100,000th. So that means the 100,000s is right here. No, the 100,000s is right here. So this is ones, tens, hundreds, thousands, 10,000s, 100,000. So I'm rounding. I'm actually rounding this to 400,000. I want to change that. That's just way off. That should not be there. So when you get this document, it's not going to say 100,000. It's going to say, I want you to round this to the nearest 1,000. So if I round this to the nearest 1,000, because all the ones up top are round to the nearest 1,000, I'm going to go 372,000. I got to make a correction on that sheet. So hold on. Sorry, I got to make a correction. So I'm going to round to the nearest 1,000. That's A times X, and they want you to round to the nearest hundredths on this one. So we're going to go 0.18. Woo, okay. Now let's do low SES. Let's do low SES. So the age values are going to be the same. So I'm just going to kind of stay with this one, but we're going to call it low SES now. Low SES. And I'm going to use those numbers. So 512 512, 123. 537, 123. 552, 123. 570, 123. 21s, 581, 581, 123. Every time I sit down here and do videos, it tells me I'm being lazy. 25 is 6. 609. 612. And 620. Now you'll notice by changing those, it actually changed these numbers over here. I think. Did it change them? I don't know. I'm going to redo it anyway. So I'll just go here, menu, statistics, stat calculations, ages, low SES, and click OK. And click OK. It just tells me I'm going to overwrite things. I did linear regression. Big mistake, children. Happens all the time. Big mistake. See how I did linear regression? How dumb was that? So menu, statistics, stat calculations. We're doing power regression. I wonder if power regression. We call this A. We call this LSES. And click O. Okay. All right. So there we go. Oh, that's much better. That's much better. Woo, man. Got scared there for a second. So y equals a times x to the b. A is equal to 432,595. 432,595.2352. 2352. B is equal to 0.0992. 0.0992. 653. 653. I don't know why that thing showed up. So I want to round to the nearest 100,000. I don't want to round to the nearest 100,000. I want to round to the nearest 1,000. So I'm getting rid of this 100. So it's y equals 433, rounds up, 1,000 times x to the, and that one we're round to the nearest hundreds place. Round this nearest hundreds place is 0.10. 0.10 to the nearest hundreds place. Okay, there's that equation. Woo, man, that took forever and a day. Use your models to predict grade models for a child who's starting kindergarten 5 years old. So, predicting, let's say we're going to do low SES and high SES. All right, so for low SES, we're going to use the equation 433,000 times x to the 0.10. Well, x, we're going to put in a 5. So, back to our calculator. We're going to do 433,000 parenthesis 5 parenthesis raised to the 0.10. Enter. 508,610. Now, I've already made this answer key once, and you think I would have remembered my own problems, but clearly it's been a little while. I want you to notice something. These ages are ages spanning 5 to 37 months. These are months. These are months. So when I come down here and I'm doing this, and this says 5 years old, I can't use this equation. I'm not plugging in 5. I have to plug, this equation only works for months. I have to plug in 5 years as months, which is 60 months. So when I create this thing, I got to plug in a 60 here. So I should be plugging in a 60 raised to the 0.10. Man, classic blunder. Totally forgot I changed that problem. And I did that purposely. So that you guys would have to really think about units when you're dealing with these, because you can make such easy mistakes by not doing that. And I apologize. That was inadvertent, but I did it to myself. And now I remember having said, oh yeah, everybody's going to fall for that, including myself. So it's 60 months. You got to be careful of the original units of the problem. So 652,000. So this should be 652,000. Get off my screen. 083. And we probably want to round that. That's about right. We'll just leave it there. It didn't tell us where to round it. We'll round it right there. They've been rounding it to the nearest thousands. I probably should tell you where to round it to. Probably 652,000. That's probably the best answer for this one. All right, so for high socioeconomic status, we're going to take 372,000. And we're going to multiply it by 60 to the 0.18. Just found another mistake. Okay, so now we're going to take 372,123, parentheses 60, parentheses, raised to the 0.18. I remember, that's the equation right there, right? So this one is going to be equal to 777,338. 777,338. And if I round it to the nearest thousands, that would be 777,000. Woo! What does the data indicate about students in low and high social and economic status? Well, what it's saying is, if you're from a high socioeconomic status, it says here when you're born, it really is making no difference. Notice how these are about the same. But then, as soon as you get to 13 months old, a year old, high socioeconomic status is making a huge change, huge change, huge change, huge change. And by the time you've gotten to 37 months, which is 3 years old, you're already 1/6, got more 1/6 more gray matter. So if you just use this data, you would probably conclude that if you come from higher socioeconomic status, then you will have more, your gray matter grows quicker. So that's what this data shows. Is that true? I don't know. That's why stats could lie. I can make these stats say anything I want. But based on this statistics, the higher your socioeconomic status, if you have high socioeconomic status, which means you're a little bit richer, then by the time you are at 3 years old, or approximately 3 years old, you will have more gray matter. And then this one said at 5 years old, and when you start kindergarten, you have 125,000 more, what are these things in cubic centimeters of gray matter. Does it mean anything? I don't know. All right, kids, bye. Okay, the last problem. Adequate vitamin D, that's getting out in the sun, has received increased recognition in years. However, the ideal intake is not known. Serum, blah, 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 blah. So we did this study here. Let's just graph this stuff. Let's construct a scatter plot of this data. So on the bottom, we're going to go with months. Again, take a look at the units. Months. Let's go 1 month. Let's go 2 months. Oh, shoot. Sorry, can't do that. I thought it was going out by even numbers. So let's go, let's see. I think there's 20 here, so I can probably make every one of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. 9, 8, 7, 6. All right, and we want to get up to 50. So I'm just going to make each of these 10. 10, 20. Actually, all I really want is between 40 and 50. And if I do it that way, that's going to kind of look kind of ugly. So I'm going to put a little break in here. And I'll call this 40. And this will be 41, 42, 43, 44, 45, 46, 47. Oops. This will be 47, 48, 49. I'm not going to get there. What's the lowest here? The lowest is 47. So maybe we'll call this 45. Let's see if I can get there like that. 45, 46, 47, 48, 49, 50. This would be 50. 51, 52. This would be 53. It doesn't get over 53, right? Oh, no, 54. Son of a gun. I got to make this 46. See, this is why you don't really want to put your numbers in. You want to think ahead of time. Let's call this 46. 47. 55 is the highest, right? 48. 49. 50. 51, 52, 53, 54, and 55. Now, had I not made that scale earlier, if I had made that scale like bad, you'd have some crappy looking graph. Now, by bad, I meant like if I'd made it like this, 10, 20, 30, 40, 50, and this was 10, and this is 40, and this is 50. All these points will be jammed up in here. You really wouldn't be able to see what's going on. So you really want to kind of stretch out your graph if you can. So at 1, it was 47. At 2, it was 51. At 3, it was 55. No, at 4, it was 55. At 6, it's 53. And at 8, it's 52. And at 10, it's 50. That's all over the place. That's crazy all over the place. What? All right. It says it wants us to write a power regression model for this data. So let's do that. Let's get rid of this. Don't save it. Don't save it. And then we're going to go back in. And let's see, what do we call these things? Month and vitamins. Month and vitamins. I don't know. 1, 2, 4, 6, 8, 10. 1, 2, 4, 6, 8, 10. 47, 51. 47, 51. 55, 53. 52, 50. All right, so power regression. So make sure you don't accidentally hit linear regression. It's really easy to do. Power regression. We called this month and we called this vitamin. Click OK, and there we go. Again, highlight the cell. It'll tell you on the bottom what it is. So I'm going to write, oops, I got my eraser out. Y equals A times X to the B. A is equal to 49.06177. 49.06177. 69. And B is equal to 03203. 0.03203. 395. And it wants us to round us to the nearest thousandth. So the thousandth is this number and that number. So let's see. Y equals 49.062. Yes. Times X raised to the 0.032. Yes, there's my equation. All right, good, got it. Use your predictor model head at the end of a 2-year study. See how I did it again? I told you to be careful, right? These are months. So if I'm going to do a 2-year study, I've got to use 2 years is equal to 24 months. So I've got to use months again. All right, so just be careful of the units. So Y is equal to 49.062 24 to the 0.032. All right, we'll come over to our calculator. Last thing we got to do, our calculator, we're done. Oh my gosh. 49.062. 0.062. 24 raised to the 0.032, right? Hit enter. 54.314. So y is equal to 54.314027. Didn't round, so I'm going to use what they said. They have them rounded to the just round to the nearest ones place. I'm going to round to the nearest ones place. I'm saying my answer is, well, it didn't say to round, so maybe this is just good enough. 54.314027. Probably 54 would be the right answer. I probably should tell you where to round to, but it's okay. All right, that's it. Hit subscribe. Hit the like button. Tell me what you think. What do you think of the new haircut? I know it's gorgeous. All right, kids. See ya. Catch you on the flip side.